Okay, so example number 3, we did it in class before, but just so that you can look at it again. Now, in this case, again, using the same thing, this is a little trickier because you actually have to flip the equation as well as you have to multiply them. So in this case, again, you look for the things, you underline the things that you want. You will need to use all four equations. So you want B solid, so you underline that. You want H2 gas, so you look down, H2 gas is here. And you also need B2H6. So B2H6 is here. Now again, this equation doesn't have anything that you want, but you will need it later on. So just hold on to it and take a look. So now, what you need to do next is you need to arrange things and maybe you need to multiply them. So you want 2B solid on the left. It is on the left, so that's good. You want hydrogen gas, 3 hydrogen gas. You have what on the left? You have 1 hydrogen gas on the left. So what you need to do is multiply the whole entire equation by 3. So in this case, the third equation times 3. So in this case, you have 3H2 gas plus 3 times a half, so it's 3 halves O2 gas gives you 3H2O liquid. Now when you do that, now keep that in mind, you underline this again, and you have delta H equals minus 286 times 3. Okay? So that's what you do here. Now after you have the things you want, you crossed out the original equation so it doesn't look too confusing. So you have a hydrogen. So you got this, you got this. Now you want B2H6. Now you have B2H6. You want it on the right, but you have it on the left. So what you need to do is you will need to flip equation number 2 and kind of basically minus 1 times it, essentially. So you will, whatever's on the right will go to the left. B2O3 solid plus 3H2 gas to go to B2H6 gas plus 3O2 gas. Then now, because you're just flipping it, so the sign will change. So instead of minus 2035, you have plus 2035. Okay? Now, after you've done that, and you check, you still want the B2OH6, you cross this out. Okay? Now, last but not least, this equation. Now, in some ways, you kind of like, when you look at this here right now, you have 3 water, liquid. You cannot cancel, even though they're the same compound, but they're a different state. You can't just cancel it like that. So this is where this fourth equation comes in handy. You look, oh, you have liquid water, you have water vapor. So in this case, but you need 3, okay, 3H2O, 3H2O. So you kind of need to multiply this equation by 3 again. So let's do the same thing times 3. So in this case, 3H2O, 3H2O gas. So what you do now is here it's plus 44 times 3. Okay? Now, what you need to do now is going through the purging situation. So you have 3H2O liquid on the left, 3 of this on the right, that cancels out. 3 water gas here, 3 water gas here, that cancels out. B2O3 here on the left, B2O3 on the right, here's on the left, those cancels out. Oxygen gas, I have 3 halves here, I have another 3 halves that is also on the left, so 3 halves plus 3 halves, that gives me 3 whole O2. So 3,2O2 here, 3O2 here, so these also cancels out. So now what do I have? Oh, by the way, this equation is crossed out. So in this case, what I have left, I have 2B solids plus 3 hydrogen gas gives me B2H6. Okay? And when I compare this and this, that's exactly what I want. And now the delta H here would be this minus 1273 plus this whole thing here minus 286 times 3 plus this thing here 2035 plus this thing here 44 times 3. So in this case, yeah, what is that? Plus 2035 plus bracket 44 times 3. That gives me 36. Yep, that looks right. 36. Now, what's the unit again? These will be all in kilojoules. So that's kilojoules. So it's positive 36 kilojoules. Positive 36 kilojoules. You kind of need to do that to write down the signs. And so that's how you calculate the delta H using Hess's law in terms of equation. Now I'm going to make other videos of using the enthalpy cycle because for diploma chem, you actually do need to know how to do that. Okay?